We're going to speak to you for about half an hour on how to heat swimming pools with data centers. And I'm here with Saiyam from Civo. I'm the Chief Exec of Deep Green. Saiyam, you say hello.
Yeah.
Oh, hello. Yeah.
So my name is Saiyam Pathak and I'm a field CTO at Civo.
Very good. So I'm going to speak for about 10 minutes and then I'm going to hand over the stage to Saiyam. And yeah, look forward to speaking. And maybe we'll get some time for some questions at the end. Very good. So I'm going to speak about what we're doing in a bit. But for the beginning, I just want to talk a little bit about the why. My name is Bjornsgaard. I'm the Chief Exec of Deep Green. And we've just raised a load of financing from Octopus Energy in the UK. And they're now backing us to build out a fleet, hundreds and then thousands of small edge data centers, all with the critically important aspect that we are recapturing the heat from every data center we build. So I'm going to get into the kind of how we do it in a minute. We're just going to spend a couple of minutes talking about the why. So as some of you probably know, data centers have a bit of a sustainability challenge. They are already 2% of the world's electricity supply, and it's only going to get worse. So the demand for data centers is growing exponentially, and depending on which ridiculously wealthy American billionaire you choose to believe, Michael Dell came out last week and said that we need 100 times the data center capacity we've currently got to make the robots work. 100 times. So we've been building data centers for something like 20 years, and we now need up to 100 times that capacity. All the low-hanging fruit's gone. We've taken up all the power that we possibly can. And interestingly, when Elon Musk came out a couple of weeks ago and started to talk about this problem, the one stat that wasn't really covered so much was that 80 to 90% of this new capacity is going to be AI. It's going to be NVIDIA and other cards which generate a heck of a lot of heat and use a lot of energy. There just aren't enough electrons to go around. This is an immovable object meeting an unstoppable force. It is affecting share prices now that no one really understands or can figure out how we are possibly going to build all of this new capacity when you've got the electrification of heat, so all our homes and offices need to be heated by electricity, and we need to electrify our transport system. Data centers are an environmental disaster if you don't recapture the heat, but the computers in them are one of the most important sustainable assets that I think we've got as a species. We think of computers in the same way as we think of wind turbines and solar panels. They are incredibly useful to us because they are brilliant electric heaters. 97% of the electricity that goes into a computer comes out as heat. Microsoft wrote a white paper on this actually in 2010. They coined the phrase data furnace. So this idea of recapturing the heat from computers. Danfoss a big engineering firm, came out last year and said if we took all the heat from all our industrial processes and captured it, we could heat all our homes and offices for free. But if you run a blast furnace, it's really, really difficult to recapture the heat. If you run a data center, it's much, much easier. So that's what we're going to do. For next, we see this as a generational shift in the same way as building the sewer system in the 19th century or building the railways at around the same time. Swimming pools, private houses, food production, office blocks, antibiotic production, laundries, distilleries, LNG plants. 30% of our entire industrial base can house a data center. And if we do this, then we get the chance to cope with the amount of demand that is coming from data centers. 3.4 trillion it's going to cost over the next 25 years. That's one of the reasons why we've taken investment from Octopus. They've got very, very large pockets in their investment funds, but not even they have 3.4 trillion. It's going to be a lot of us doing the work. And if we do this, though, we're going to live in a world where all of our homes and offices are heated, in our case, for free. So we have this fundamental change in the cog of capitalism, where at the moment carbon is pretty much free, and that price of carbon is going to rise. At the moment, energy is expensive, but in the years to come, it might be that as we give more and more heat away for free, which is our model, then the marginal cost of heat energy actually reduces to zero. It sounds far-fetched. We've already started, and we'll cover this in a minute. So even in London, if you take London's current capacity to deploy this technology, you've got 200 public pools, 300 commercial pools, 600 heat networks, 200 commercial laundries, and on it goes. In London, if you retrofitted now, you could provide billions of free subsidies to industry, and you've already got 1.5 gigawatts of data center capacity. How do you do it? Well, the beauty about this is it's really simple. It's what I call withered technology. It's a technology that we all understand and we all know. If any of you have seen, it's quite disconcerting when you see a computer in an oil bath. I compare it to C-3PO in Star Wars when he gets immersed in his oil bath. You specially prepare the computers, you rip off the fans, and you dunk them completely in oil. You don't have to do this, but this is one technique that we've perfected. When you do that, the computers heat the oil up. You don't even need a pump to pump it round. As the convection current in the oil starts, it pushes the hot oil around that closed loop into a heat exchanger. Heat exchangers we've had for 100 years. Again, fungible, withered, simple technology. And if you get the delta T right, if you get the difference between the heat of the oil and the heat of the water, the other side of it, you pass the heat energy through. Really, really simple, really, really easy to deploy. And unlike a lot of green tech, which is still in the lab, people are still shuffling and changing chemistries, and it's not ready to scale. This is now ready to scale because we've got these massive supply chains of computers, which are our heat source. So that's the rational, practical bit of it. We made a video to describe our ambition for the next couple of years. I wanted to share it with you.
For me and my two brothers, it was really quality time with Dad. And obviously in the early 70s, you didn't really get that because dads and kids were seen and not heard, so to speak. So for us, it was real quality family time. The ritual of having been given some money to go to the vending machines and having a cup of soup and a bar of chocolate, the whole thing was an experience.
So we're framing the problem and the opportunity as your heat. It's the heat coming from the computers that you and we all use in our everyday lives, and then framing that as something to do for useful to do with. Let's try and get through that. So, and that's what Civo did. So a year ago when we announced our first site, one of the first people to call us was Civo. They said, we're in, this is absolutely what we want to do, and we're going to talk a little bit more about that in a minute. And Civo now, if you use the Civo platform, your workloads are now running on our tin in our data centers and providing social goods. So, and the amount of money available here is incredible. So if you do a large pool, you're saving that pool £80,000 of, we're giving that pool £80,000 of free heat from the computers every year. And in terms of sort of the practicalities of this, many of you may not know this rather geeky term, PUE, power utilization effectiveness. It's effectively the amount of money you spend cooling your computers versus the amount of money you spend keeping them on. Ours is incredibly low, 1.03, but as importantly, there's been a lot of talk about ChatGPT and a lot of talk about how much water that data centers use. I think it's something like half a litre for every 5 to 50 queries. You know, when you get a dialogue going with ChatGPT, you often do multiple queries. But half a litre of water is used in cooling those computers down. So it's not just the electricity, but it's also the water there. And finally, I just wanted to touch on a few other aspects of this. So the sustainability bit of this is incredibly important, but actually even beyond sustainability, when you decentralize compute, a whole host of amazing things happen. So it's your workloads in terms of distributed compute, much easier to run distributed compute on different nodes wherever they are. You've got the networking, so AI inference, we can light fiber between sites. There's a whole bunch of reasons why, from the grid point of view, it's really useful. When you build a small data center, you can put solar around it, and you can take the data center off grid, so your costs are lower. So, as a whole kind of holistic approach, this idea of decentralizing our compute, not only from a price and a cost point of view, but also from a sustainability point of view, is incredibly important. So, with that, I'm going to hand over. And thank you.
So that was a very fantastic story. Let's stop for a while and think. Like, you are swimming in a swimming pool and it is getting heated up when you are running your ChatGPT query and you are using an AI model or whatever that is, training, and you are doing some inferencing, and it is using the GPUs, which is actually heating up the swimming pool in where you are swimming. I mean, how cool is that? So when I first heard this, I was like, it was mind-blowing that something like this is not in the dreams. It is actually happening, and we have the use case, a proper use case that we can build around it. So how we did it, so Civo is a cloud computing reimagined platform. We are trying to fix the broken cloud. Yes, I can say, because cloud is now not easy, it's complex, it's not that much cost effective, the prices are rising up. And how we kind of do it is by lowering the cost, so lowering the cost by 60%, fair and predictable prices, which all the hyperscalers and cloud providers actually should provide. Reduce the complexity. You should not be doing certifications for understanding how to use the cloud. It should be intuitive. You should just go to the UI and you should be able to figure out if you need a compute, if you need a Kubernetes cluster, whatever you need. And supporting open standards. So at Civo, we are very open. So we use OCP racks, open compute hardware. We promote multi-cloud. We use open source software so that there is no vendor lock-in. We support that. We use all the open source layering on the infrastructure software that we have built, and that is why we should be open and free to use the best of the cloud services from the cloud providers. And Civo kind of supports that. In terms of offerings, we have the standard like compute, network, storage. We also have managed Kubernetes, GPUs, managed Kubeflow, object store, all those things. And yeah, we are one of the VMware alternatives as well. So that thing. But what Civo is doing differently in terms of community aspects is, one is sustainability. Like Mark mentioned, we were one of the first ones to partner with Deep Green to provide a carbon neutral AI kind of, you can run your AI workloads, because this is an AI era, right? And no talk can go without saying the word AI. I mean, I tried, but I mean, that's the only time I'm using it, okay? So with rising of such workloads, you need more and more GPUs, you need more and more data centers with more and more, like you're sleeping today and every day there's a new, or maybe tens of new models that are coming up. People are experimenting, people are finding a use case, and that is increasing the amount of GPUs that are needed, that is increasing the amount of data centers that are needed, and this is where this sort of partnership with Deep Green has led us. Okay, you can do your innovation and you can be 100% satisfied in what you are building, what you are innovating in the AI space, and in a sustainable way. So you can use the efficient data centers and with the Deep Green innovation that they have done for heating up the swimming pools. Again, champions in the open standards by increasing the interoperability, fair and predictable prices, and community aspect. Also the work-life balance, we were one of the first ones to have the 4-day work week, have been doing it for quite some time now. Again, coming back to sustainability, so it's like even before we had Deep Green, we always used to have internal discussions, and that is one of the key takeaways as well. So sustainability from the grounds up, choosing the rack that we use. If you go, I'll be touching on the CNCF landscape as well. So there is a CNCF landscape of sustainability that has smart data centers in it, and if you go to the smart data centers, you will find open compute over there, which have intelligent cooling system and stuff like that. So we use that OCP racks for our data centers. So we have been using that already. We have partnered with Deep Green for even more 100%, attaining the 100% sustainable GPUs, adoption of green energy. So whenever we talk with any of the co-location data centers that we need, what is your carbon footprint? How much green energy are you providing? So I think it has to come naturally from all the levels. So it's not only a single level, a single person problem. It has to come at all levels, at all places, including hardware and software, which I'll talk even more after this. And this is where, like if you log into Civo, this is the Deep Green region. So you'll be able to simply create your GPUs, and when you create it, you can log into it and you can heat up the swimming pool. Not stopping to the hardware layer. So again, like Mark mentioned, sustainability is not only about hardware, it's everywhere, it's at all levels. So even if you are using 100% sustainable GPUs or 100% sustainable stuff, you still are consuming resources, and even reducing the amount of resources you are using contributes to less resource usage. And you can use the existing CNCF ecosystem. For example, we do under 30-minute region deployment using, we have prepared a whole ecosystem where we can do under 30-minute new region deployment within Civo using Argo CD. We provide managed Kubernetes based on K3s. K3s is a Kubernetes distribution that itself consumes less amount of resources, has a lower memory footprint, and then allowing GPU and the compute workload to be running closer to where the customer is. Supporting the community. So we also do a lot of community events. For example, we do Civo Navigates, technology conference, then Disruptive Tech. We have a Slack community. We have a huge focus on sustainability where we have partnered with Deep Green, green data centers, right size workloads where, so you, like Mark mentioned, you have hundreds and thousands of mini edge data centers that will be spread across. And there will be times when you have a specific swimming pool required to be heated, So how intelligently we can schedule the workload to the data center, which is actually requiring to heat up a particular swimming pool. So that kind of intelligent workload scheduling is what we are working on. This intelligent schedulers are also part of CNCF sustainability landscape. Future plans, again, making sure we schedule the workload where it is there, more green data centers across the world, and faster auto scaling of the nodes to use, and also WebAssembly based thing. So I'll talk more about WebAssembly in this particular slide. Yeah. So we not only have partnered with Deep Green, we also have a production customer who is serving out more than thousands and thousands of customers, which is Fermion. So Fermion provides AI inferencing based on WebAssembly. So WebAssembly is basically a bite size, a new binary format. So you have a code, you compile it using your regular compiler, but you this time compile it to .wasm file. So you have the wasm format that can run on any architecture, any platform. So it's platform agnostic, smaller binary sizes. In today's keynote also they were talking about SpinCube, and you can actually spin up SpinCube on Civo Kubernetes right now. So yes, WebAssembly is something that is taking a wave, and Fermion is kind of one of the pioneers in the WebAssembly space. So they are doing, in their platform, they are providing AI inferencing. They're using, all of their workloads are deployed on the Civo's Deep Green region. So now think of the complete stack. So we have the Deep Green region who has done the innovation at the data center level. Then you have Civo layer on top of it, where we are reimagining the cloud and making sure the cloud layer is resource efficient and partnering with them. Then we have the customer who is also working in the latest technology that actually contributes back to the sustainable, because you can have a single instance, you can do much more slicing and dicing of the GPUs efficiently for the WebAssembly workloads than the regular standard workloads. You don't have to attach a complete GPU. You can, whenever the AI inferencing of the WASM module finishes, it deattach and attach that particular stuff to GPU to the next one. So like this intelligent workload that they are using and powered by WebAssembly. So this becomes a really interesting combination, and this is in production happening, 100% GPUs using the latest technology out there, WebAssembly, to do the AI inferencing. I also want to touch on cloud native sustainability. Again, that was one particular use case, but what you can do, like I want you to take back something from here, try out some stuff. So in CNCF, and this is a very big thing. In CNCF, they have a technical advisory group for environment sustainability, and it supports the CNCF community and its open source project to become more sustainable. So sustainability is happening even at the CNCF projects level. How it is happening? So first, like the mission statement is to advocate, develop, support, help, educate environment sustainable initiatives in the cloud native technologies, and then identify, the tag will identify the values and possible incentives for service provider to reduce their consumption, carbon footprint through cloud native tooling. So this is what currently it is there. So the green ones are in planning. So there is a landscape which is there. In the landscape, you have the tooling, the chaining, the smart data centers, the intelligent scheduling, all those, and the whatever tools are there. And next is the community advocacy, which just means educating people on what this means, how people can get involved, and people can use existing tooling. And then CNCF Green project reviews. This is basically using the existing, like calculating and measuring the existing CNCF projects about their carbon footprint. And then blog demos, and then also writing a white paper on how you can use Kubernetes in the most resource efficient, sustainable way. So helping CNCF project to review their cloud native sustainability footprint. This is by the Green Foundation SCI Index. So you have energy consumed by software, you have carbon emitted per kilowatt hour of energy, and M is the carbon emitted through the hardware, and R is the fractional, like how many number of users or devices, etc. Touching on two more things. One is Kepler. So Kepler is a CNCF sandbox project. So again, this is something that you can actually go back and try. So you have a Kubernetes clusters, you can install Kepler, and Kepler is a K8s-based efficient power level exporter. What it does is it captures all the metrics using eBPF tooling and runs them against the machine learning model, and then enriches the data with how much carbon footprint each of your workload in every namespace gives you, and then exports it as Prometheus metrics so that you can have your fancy dashboards and stuff. And then is the Cube Green. So Cube Green is the operator to reduce the CO2 footprint of the clusters. So what you have done is, with Kepler, you have actually taken the metrics. So you installed Kepler, you took the metrics. Now you, on your dashboards, you understand which workloads are consuming what level of, are doing what level of carbon emissions as per the SCI index and the models which have been deployed. Now, usually you have dev, stage, prod, all the environments which are there, multiple clusters running, which you do not need 24/7. So you can actually turn off the workloads in your maybe dev clusters, stage clusters on the weekends and stuff like that. Obviously not production, but there are a lot of dev and stage clusters. So you actually can create a sleep info custom resource. This is operator you install, you create the resource, so it will actually make sure to sleep your workload for that specific duration so that you are not consuming the resources. So in summary, you can actually use both of them in conjunction, Kepler measuring the energy, and then Cube Green taking action in reducing by scaling down to 0. So you can have Civo Kubernetes in 100% sustainable GPU, 100% sustainable data centers. Plus, on top of that, you can reduce your consumption of resources on Kubernetes using these tools. And these are existing tools under CNCF. So call to action is, scope of innovation is at all levels, whether it's hardware, whether it's data center, whether it's the complete entire stack of infra layer. The CNCF projects are also involved in this. Application layer as well, where you can measure the application level of CO2. You can actually, there are a lot of hardwares that provides APIs to, like Redfish APIs, to actually extract the footprint of the data centers. Sense of responsibility as at all levels. So I think this is very important aspect. You need to have a sense of responsibility when you are writing the software. I know as developers we don't care. We are just writing software. We think sustainability is something political and we don't want to deal with that. But no, there are APIs, there are softwares that dev loves, and you can use the same tooling, like not the same, but the existing tooling to get all these things in place. Adopting this as a culture and practice for all projects. So I think one of the call to actions can be just go back, have a meeting with your team monthly once and talk about, take one project and see, measure the footprint. I think measuring that is important, and then see what you can do in reducing the resource usage for your particular application, and then you can slowly develop it as a culture. Like we evolved, we adopted DevOps as the culture, GitOps as the culture. Why not sustainability as the culture? And again, Mark Boost, who is the CEO of Civo, you can read his quote, like, we all have responsibility to reduce our carbon footprint. This partnership with Deep Green is just one way we are looking to reduce our emissions and move towards climate positive future. So that's what I was saying. It has to come down from top bottom approach in your organization. Like everybody has to be on the same page that we are doing something, we are innovating, everybody's using the latest tools, technologies, trends, but we need to focus on the sustainability aspects. Like we need to try to do it in a sustainable way. Civo also has Civo Foundation that drives the social change, campaigning on the sustainable technologies and stuff. And yeah, we have responsibility to leave the world in a better place for future generations. That's what we are trying to do. So you can get involved with Deep Green, us, or tag sustainability in CNCF ecosystem. And that's pretty much it that we had. Thank you so much for attending the talk, and do not forget to share the feedback. I hope you took something from the session. You can apply, go back and apply something in your sessions, in your organization today. And yeah, start using Deep Green on Civo. We have time for questions? Yeah, so we have time for a few questions. If anyone has, yeah, there's one question. Mark, you want to also come?
Hi, I had two questions. One is, do you have to replace the oil that you put that the servers are in at any point, or is it good forever?
Yeah, good question. There are two types of oil. One's bad and one's good. We'd use the good one, and it lasts for 15 years, or at least the manufacturer says it lasts for 15 years. It might last for longer, we don't know, because no one's ever tried it. But yeah, it is, and it is recyclable in the end, but we're pretty sure it's going to last beyond 15 years.
What does recyclable mean?
Well, put back into, so in exactly the same way as we're doing with the hardware itself, is extracting whatever we can and then mitigating what we can't. So with in Deep Green, everything we're using, we're extending the life cycle of hardware. So we're working with partners to usually you use your GPU for 3 to 5 years, we're extending that out, and then eventually you have to grind it up. And once you take it apart and you grind it up, then dematerialization, taking all of those materials out of it, we're working with partners with that, and then what we can't get rid of, we're offsetting, we're reducing. We're buying decent offsets, it's not planting trees, they're $250 a ton. So when you use our compute, it is completely carbon neutral. That's our aim.
Awesome, thanks. And then my other question was, is there a distance that like how far can the heat travel?
Yeah.
How close do your servers need to be to the pools?
It's a good question. One of the reasons why you do this is because heat can't travel very far.
Yeah.
Certainly in the UK, there's more fibre in the ground in the UK than there is in the whole of North America. So, and you're pretty much wherever you are in the UK at least, you are within 5 to 8 milliseconds of an on-ramp into any other cloud. So actually the constraint, we started Deep Green 8 years ago, and actually the fibre networks, and really, the world wasn't ready for this then. But yeah, you now the fibre, and what we're doing is we're meshing these. So each data center, each of our nodes is connected to another one on the network, and then backhauled to carrier neutral data centers. So actually, this is from an AI inferencing particularly, we can light fibre between a company's site and our pool, and then it can be kind of air gapped. So latency is not a problem with the network. It is a problem of heat. So that's why you've got to build them where the heat's required. Yeah.
Cool. Thank you so much.
No problem.
Thanks for the talk, for the effort. I have a question. If you have more distributed data centers, then it means you have more wires. And how do you balance this? More wires means more copper, etc.
Yes, yeah. Well, it's a multifaceted question. So half of our estate we build in the fabric of buildings. So you actually use less carbon when you build in the fabric of buildings. And when we build containerized like we do, you actually use less. You use less materials building data centers in this way. It's certainly true that you have a degree, in terms of networking, and networks actually take more electricity from our grid than data centers do. So data centers are sort of between 1% and 3%, no one really knows. Networks actually at least as much. So whilst, and this is why sustainability is such a challenge, because you have to see it in the round. There might be a marginally more wire in the ground, but actually as an overall carbon saving, it's massive. Keeping noughts and ones, keeping network traffic local is actually one of the most sustainable things you can do. Actually backhauling, pushing zeros and ones all the way around the web is actually hugely carbon intensive. So keeping them local is is really important. Yeah.
Thanks. I think this is a fantastic technology. How much does it cost to set this up?
Civo or Deep Green? Both. Well, one partner did some analysis recently, and a like-for-like, just really crudely, a like-for-like H100 on Civo compared to AWS is probably anywhere between a third and a seventh of the price of AWS. Then on top of that, you've got all of that social good. You're doing something good responsible with the heat, and then you've got genuine carbon neutrality. So we're back to that saying, look, there's no greenwashing here. We're being completely open about the amount of carbon we're using, how we're recycling. So an order of magnitude cheaper, both in terms of carbon and cost. But Saiyam, you might.
Yeah, I think Mark covered it. So the GPUs, the cost that we provide is like 1/3 of the cost of the cloud providers out there for the GPUs, is for the A100s. So I think it's good for the community in all the ways. So you can use cheap GPUs. You can by doing the social good for heating up the swimming pools.
I have less of a question, but more of a thought.
Please.
I like all these ideas and concepts, and especially because they're disruptive. But what if, the pools are heated with the data centers and you make it very efficient, and we had other talks that mentioned the efficiency of data centers itself. So in the future, you might be in a situation where the pool is not getting heated because you're too efficient. And then people are asking, well, I don't want to take a swim in my cold water. So please do queries to ChatGPT in order to get my pool heated. Do you have this thought, or how this situation is going to end up?
It's what we call a rich man's or woman's problem. What a lovely problem to have, that we are so efficient and so good. But I think on all measures, the sheer volume of compute we now need to make the robots take over, we are at least a generation away from that, sadly. But it would be a lovely problem to have. It is very odd looking at this end of the telescope, because a lot of people are fretting about power and heat, and of course we love that. And that's one of the reasons why you can be so much more efficient with really old kit. If you've amortized the kit over 5 years and you've paid it off and it's free, then so long as you can recover the heat, and as long as the amount of energy you spend actually powering the machine, somebody will pay you 1p more for it, then you can keep going. And then you don't need to rip it out and throw the hardware away. So it would be a lovely problem to have. Yeah, bring it on, I think. But the latest NVIDIA kit is 150 kilowatts per rack. That may or may not mean much to you, but that is, it is unfathomable about the amount of energy that is required that's coming. It is. Yeah, none of us really can understand it. Yes. Sorry, we're at the end. But please come and find us. Come and find us if you have any more questions. We'd love to talk. Thank you.
Thank you so much.